All right, let's talk about a battery, how a battery works. This is a basic drawing of a battery. In your notes, I would really strongly advise you to pause the video real quick and just draw this very simple picture. Inside of a battery, what basically is going on is there are two pieces of metal, that's all that is, and they are embedded in I'll tell you more about this in a minute, but this is an insulating material so that they're not immediately connected to each other, so that charge can't automatically flow from one side to another. Right now, let's just assume that the negative side is negative because that's where the electrons are piled up. We have an excess of electrons over there. They've gained electrons. That side, that terminal has gained electrons, and so that's the negative terminal, or we call that the high potential terminal. The reason it's high potential is because electrical energy is based on electrons. Well, that's where the electrons are concentrated, so we have high potential energy over there. On the other side, the positive terminal is conversely called the low potential terminal because there is a deficiency of electrons on that side. So high potential is negative, you need to know that. Low potential is positive. And then this right here denotes a wire or some sort of conducting material. If we don't have a conducting material, the negative side remains negative, the positive side remains positive, no problem, because again, this material is not going to allow the electrons to escape until there's a connection. Once we get a connection, then the electrons are going to move. The electrons will move from the negative to the positive, which is what we just said. Electrons spontaneously move from negative to positive. All right, so but this is a charge pump. As we said before, this is great. Electrons can move from negative to positive until those charge differences equal out, until all of these electrons have moved over here, until the negative is no longer negative because it's lost electrons, and the positive is no longer positive because it's gained electrons. So what we have to find a way to do is to bring electrons back the other way from the positive terminal to the negative terminal, and that's the job of the battery. I'm going to say this right now, and I'm going to say it several more times. You need to know right now that the job of a battery is not to light a light bulb. It's not to run your device or whatever you're using the battery for, to run your remote control, whatever it is. That's not the immediate job of a battery. What lights up the light bulb or runs the remote control or whatever else is the automatic, spontaneous flow of electrons from negative to positive. That happens automatically. We don't need a battery to do that. We don't need anybody to do that. The battery's job is to maintain this situation, to keep the negative negative and to keep the positive positive, which means the battery's job is this down here, to move electrons from the positive back around to the negative. Now, in your notes, as you draw this picture, you should be drawing all of this. Up here on the top, this is where we're lighting up our light bulb. This is where work is done by electrons. Harken back to the first and second law of thermodynamics. Work is done by electrons up here because they have energy and they can do the work to convert that electrical energy into something else like light energy that we can use. So this is when work is done by electrons, but now they've used their energy, it's done, they're deposited back on the positive side, and they need to be moved back over here. In the bottom, I want you to label this work done on the electrons. This is when the battery is doing work on electrons to move them back across from the positive to the negative side. And I want to be clear here. This is work done on electrons because they don't want to go there. They're kind of being dragged across here, kicking and screaming against their own will because they want to be at the positive party. Everybody likes the positive party, especially an electron. They don't want to be on the negative side. They don't spontaneously flow there. So we have to do work to get them there. So this is when when work is done by electrons. This is when electrical energy is converted to other types, as we said. This is when energy is decreasing. It's flowing out of the system, right? Remember our first law of thermodynamics. And down here, this is when we're converting chemical energy to electrical energy. This is when electrical energy is increasing, right? So we're losing electrical energy at the light bulb. We're gaining electrical energy again in the battery so that the process can start over again. This is when energy is flowing into the system, all right? Now, this happens because of a chemical reaction, and I think that's our next slide here. Yes. So inside the battery, you need to know that the way that batteries work is there's some kind of redox reaction. There's some kind of oxidation reduction reaction. There's a number of them that happen, but they form this acid. Like if you go out to your car battery, you might find some battery acid. That's because this stuff from inside eventually ends up leaking out. There's small leaks in it. You might develop a crack depending on temperature fluctuations, but battery acid can leak out. That's an evidence of what's going on inside. It's not just a black box. There's an oxidation reduction reaction. Remember that there's a loss and gain of electrons. So one of these reagents on this side is gaining electrons. It takes work for that to happen. It takes energy for that to happen, chemical energy. So there's this chemical reaction, and the chemical reaction's job is not to light the light bulb. The chemical reaction's job is to convert this chemical energy into electrical energy by concentrating the electrons on the negative terminal. Once that happens, then we can spontaneously get those electrons to flow back around to the positive because they want to do that anyway. So that's nobody's job to make that happen. It's spontaneous. It's a natural reaction. And the way that I want you to see this in this battery, let's see, maybe I can put me down here, is this is kind of like a water pump. Maybe you've seen a fountain, maybe you have a fountain in your yard, but a water fountain is very simple. You have a pool of water at the bottom. There's a pump that draws water up to the top of the pump or the top of the fountain or whatever it is. Once it gets to the top, then that water flows downhill, and as it flows, it might flow over something like this. These are water wheels that will turn. What we're doing here is we're using the spontaneous flow of water to get some work out of it, to create some energy for us, to turn these wheels. But once the water gets down to the bottom, it can't do any more work, and all that's left to do is to pump it back up to the top. So there's this big cycle of pumping the water to the top. That's work done on the water, and then the water flows down. This is work done by the water, right? So the same thing with a battery. I want you to equate this side of the battery, this spontaneous flow of electrons from negative to positive. That's like the water flowing downhill. This is our downhill spontaneous flow of electrons, and that's when it's doing work for us. So the water turning the wheels is just like the electrons lighting the light bulb. It's doing work for us. But then the water gets to the bottom and has to be pumped back to the top. Well, this water pump is the same thing as this charge pump here. And that's the battery, right? So the battery is the pump. So this is our spontaneous natural flow. That's the second law of thermodynamics, that energy spreads out, right? Energy goes from high to low. We got high potential to low potential. That's a natural flow of energy. This is our non-spontaneous flow down here. This is forced flow. We're going against the natural flow. That's why work is required. This is work done on electrons. This is work done by electrons. So two sides of the process, but both of them have to come together to make a complete circuit, right? So this is how a battery works. And now that you know how a battery works, I want you to look at these statements and see if you can fill in these blanks right here. Go ahead and pause the video and see if you can fill in the words that should go in these blanks. All right, let's go ahead and talk about this. Hopefully you got all these. If the battery terminals are connected by a conducting wire, the electrons will spontaneously flow through the wire from the negative terminal to the positive terminal. And you might also want to write right there that the negative terminal, remember, is high potential, and the positive terminal is low potential. This flow of electrons is an electric current. And as the electrons move through the wire, they can do work. That's running a motor, a light bulb, a radio, TV, whatever it is, they can do work. Next point. Since the electron doesn't spontaneously move to the negative side, right? So it spontaneously moves to the positive side because it wants to be on the positive party. I like to say it that way. It doesn't spontaneously move to the negative side. That's what takes work to get it there. Potential difference, which is the same thing as voltage, is the amount of work done on the electrons as they are moved from the positive to the negative terminal. So electrons go from positive to negative if work is done on them. It's not a natural process. That work is done by a chemical reaction. That's inside the battery. Chemical reaction converts chemical energy to electrical energy. And once again, what I want you to understand about this entire process is it's a two-way street. We have this process here, I want you to divide it from the top to the bottom. Inside the battery, outside the battery rather, is our spontaneous downhill flow, quote unquote downhill. The water flows downhill spontaneously or naturally. This is work done by electrons. Inside the battery, however, is the non-spontaneous flow, the forced flow, the uphill flow. We can do that, but it takes work to do that. That's when work is done on the electrons to get them to flow uphill. So this is the basics. This is the kind of the basic idea of how a battery works and how it runs a light bulb.